So anyway, we will get to that diversion in just a minute, but let's take a look at this opening exercise because I do think this is very good. It certainly caught my attention as a teacher. Ms. Rosenblatt gave her students what she thought was a very simple task. What's the next number in the sequence? 2, 4, 6, 8. And Cody says, I'm thinking it's plus 2, so then it would go 10, 12, 14, 16. Allie says, I'm thinking of a repeating pattern, so it continues 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and so on. Suri says, I am thinking of the units digit in the multiples of 2, so it goes 2, 4, 6, 8, 0, 2, 4, 6, 8, 0. Are each of these valid? Yeah, absolutely. What is the 100th number in Cody's sequence? I think it's 200, because each time you multiply by 2. The first one times 2, the second one times 2. What's the 100th number in Cody's sequence? Oh, I'm sorry. Allie's? I think it's going to be 8, because 4 divides evenly into 200. So it'll go into there a total of 50 times, and the 50th time you write an 8 will be the 200th term. What about Suri? 0. Good. What is an expression in terms of n for the nth number in Cody's scenario? And that's where I want to break off. Ready? So let's go over here and let's start summarizing what we know. There are two types of ways to represent sequences. The first type or way, God bless you. The first type of way is called an explicit formula, and it's going to be very much what you're used to, all right? And then the second way, why am I having a complete brain cramp here? I forget the name of the second way, and I just taught a whole bunch of this stuff just the other day. Recursive sequence. I forgot why, I don't know why I was having a brain cramp. But recursive sequence. And for what it's worth, I didn't see it on the page, so I did remember it on my own. All right, so there's explicit formulas and there are recursive formulas. And the recursive formula, let me do first, because I really like this one. This is what it looks like. I could also write, now, this looks really weird, but it's not. It's really, really simple. When we list out a sequence, the terms are a sub 1, a sub 2, a sub 3, a sub 4. In other words, if I was to write out a sequence like this, this is how I would write any sequence according to the recursive formula, or the recursive formula. So if my sequence went what is a sub 1? 3. A sub 1 is nothing more than the first term. Remember how we did the slope formula and we did, the first day you look at it, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we said that that's really just the y from the second point minus the y from the first point. So we have to keep in mind what these subscripts mean. This just means the first term. What does this mean? Second term, third term, fourth term. So when we have a recursive sequence and we say a sub 1 equals something, we're saying the first term is. Then, in a recursive sequence for addition, and that's the only one I'm going to do at the moment, what it does is it adds or subtracts a common difference every single time. In this problem, what's the common difference? What is it? 4. And what are you doing with that 4? Are you adding it or subtracting it? Adding it. So we would say a sub 1 is equal to 3, and this plus, no, not minus, plus 4. And what this means is, now this is where it gets at first a little confusing, but it really is easy. Notice what we have here. What this means is the new term is the previous term. Because doesn't n plus 1 always come after n? Right, look here. This is 3. What's 3 plus 1? 4. What's 4 plus 1? 5. What's 5 plus 1? 6. So this is saying the new term is the old term, and in this problem, plus 4. That's all it means. New term is the old term plus 4. Now, isn't another way to look at it that the 6th term is the 5th term plus 4? So this means the same exact thing. These are both ways of saying the new term is the old term plus 4. The new term is what? The old term plus 4. So I want you to write a recursive sequence for the following. Ready? Go ahead. Now these are all with additions. We'll get into multiplication in a little while. But I want you to get the idea of a recursive formula first. Okay, so what is a sub 1? 10. What's my formula? We would say a sub n plus 1 equals what? A sub n plus 5. Because what am I going up by every time? 5. Okay, let's just do another one real quick. Ready? It goes 12, 4, negative 4, negative 12. Okay, so what's a sub 1? 12. And now I'm going to set the beginning up. A sub n equals a sub n minus 1. Same exact thing if you did n plus 1 and n. I just want you to be able to recognize both in case they put one or the other in a multiple choice. And what do I do at the end? What about the 8? Minus 8. Because you're going down 8 every time. Okay, makes sense? Now, let's go over here and write each of these as explicit formulas. Now, explicit formulas are kind of more like what you're used to. And what this says is a sub n is a sub 1 plus n minus 1 times the difference. Just copy it down and then I will explain. It is not difficult. And this one is actually more like what you've already known than the older ones. Oh, than the other one, I should say. So let's take a look at this blue sequence here, 3, 7, 11, 15, 19, 23. Now, this is saying the new term, that's what a sub n is. When you see a sub n, you should say the new term. The new term is the first term. So a sub n is, what's the first term? 3 plus n minus 1 times the common difference. What's the common difference? 4. I tend to like to put the 4 in front, but most textbooks put the d afterwards. But that's weird to me, because don't we always put the number in front? Right? So I typically put it in front. Now, here's the great advantage to the explicit formula. If I say to you, remember they did one before, what's the 200th term? It's so easy to do, because all I do is drop 200 in for n. 200 minus 1 is 199. 199 times 4 is 796. Plus 3 is 799. It's, you just plug in a 200 for n and calculate. It's very easy. The problem with a recursive formula, could you imagine if I said what's the 200th term? You just keep writing and writing and writing forever and ever and ever. So the explicit formula is wonderful when I want to know a specific term. A sub 200 is 3 plus 4 times 200 minus 1. These ends match, guys. Okay? And then I just do the calculation. That's the great thing about the explicit formula. Okay, let's do the green one. Write out a explicit formula for the green one, 10, 15, 20, and so on and so forth. Oops, sorry. multiply 5 with 50. Okay, ready? Let's go. A sub n equals, what's first term? 10 plus, what's common difference? Times n minus 1. Done. Now, how easy is this? This is very, very simple. What if I said to you, what's the 15th term? Equals 10 plus 5 times 15 minus 1. What's 15 minus 1? 14 times 5. 70. 70 plus 10. 80. Very good. Okay. Now let's do an explicit formula for this one in green, starting with the 12. Okay, ready? A sub n equals, what's my first term? 12 plus, or pardon me, minus this time, right? It's minus 8, isn't it? Yeah. Yep, times n minus 1. What if I said, what's the 10th term? Good, so that would be 9, negative 72, negative 60. Right? Okay, excellent. So now, that's the explicit formula and the recursive formula for any pattern that is addition over and over and over again. And with that basis, we'll eventually get into problems with multiplication. But we're not going to go there yet. So here we go. Ready? Jerry has the thought of a pattern that shows the powers of 2. Here we go with multiplication. 1, 2, 4, 8, 16, 32. In other words, what is he doing each time to go from number to number to number? Multiplying by 2. Write an expression for the nth number of Jerry's sequence. So, if I want, I can call it a sub n. That'll equal 2 to the n minus 1 power. And let me explain where I get that from. Just like we had the n minus 1 before, we have the n minus 1 here, because the first term is 1. And if I was to leave this 2 to the n, 2 to the 1 would not equal 1. 2 to the 0 equals 1. So I make this n minus 1 to get that 0. And then work my way from there. Okay? So, there are two types of sequences. There's arithmetic and there is geometric. Arithmetic sequences go up or down by the same number every single time. Okay? So it's an addition sequence, a sequence based on addition. A geometric sequence multiplies or divides the same number every time. So, this 1, 2, 4, 8, 16, 32, is that arithmetic or geometric? Geometric, good. 5, 10, 20, 40? Obviously, geometric. 3, 7, 11, 15, 19? That is arithmetic. Which one gets bigger faster, arithmetic or geometric? Mm-hmm. Definitely, without a doubt, geometric. When I was a young boy, I was about 12 or 13 years old, my dad comes up to me, and actually we were sitting at the kitchen table, and I was begging him for allowance. Did you ever go through that phase where you beg your parents for allowance, and then if you get an allowance, you try to get a raise? No. No, you never been there, done that? Oh, I've tried very hard. And my dad looks at me and he says the following. He says, listen, I will give you either $5 a week, or I'll put a penny on your dresser, and I'll double the number of pennies every day for a month. You can have either one. And I almost jumped out of my skin and said, $5 a week? Whoa! I'll take the 5 a week. The other one's worth over $2 million. Yeah. That's how much bigger it is. It absolutely is. 1 penny, 2 penny, 4 penny, 8 penny, 64 penny, $1.28, which will knock down to $1.25. $2.50 on day 9, $5 on day 10. Day 11, $10. Day 12, $20. Day 13, $40. Day 14, you're already way past your allotment for the month. $80. Day 15, $160. Day 16, $320. Day 17, $640. Day 18, $1,280. It comes out to well over $2 million. Okay. So these geometric sequences build very fast, and my dad, of course, didn't have that kind of money to give me, but so be it. All right, here's a +3 pattern. let's write first thing I want you to write is an explicit formula for this. Explicit. That's the one with the n minus 1 in parentheses. Agree? Right? Okay. Now, it also says using f of n notation. F of n is another way to write it. It's the same exact thing. And the beauty of this is always, the beauty of the explicit formula is it's the easiest way to answer the question, what is the blank term? What is the 10th term? What's the 100th term, etc. The explicit formula goes right for that. How would we write it with a recursive formula? Recursive says, you say what the first term is, a sub 1 is, what is it? 4. And then the new term is the previous term, and you could write n plus 1 and n, either way. And then what do I do to go from term to term to term? Plus 3.
Can we do either one? Like,
You need to know both, only because what I expect them to do is to put it in a multiple choice and say which of the following recursive formulas or which of the following explicit formulas. If they don't do that, then it's whatever one you like. Okay, does the formula f of n equals 3 times n minus 1 plus 4 generate the same sequence? Yes, it does. Okay, now, graph the terms of the sequence of ordered pairs on the number line. So, we can actually play with this a little bit. F of n is the same thing as y. So y equals, and we said it was what, 4 plus 3 times n minus 1? Okay, so we're going to change this because it's x. Change that to an x. Now, look, let's do a little bit of math here. Distribute the 3, and I get y equals 4 plus 3x minus 3. And then I combine like terms with the 4 and the negative 3. Y equals 3x plus 1. Do you know how to graph that? Absolutely. Where do I begin? 1, and then I go what? Up 3 over 1, up 3 over 1, up 3 over 1. And there is my sequence. Graph. So in other words, if I go out here later on to the number 4, right here, you're going to get 14. Okay? Preguntas? No questions? Excellent. Okay. Consider a sequence that follows a minus 5 pattern. Let's write this recursively. What's a sub 1, everybody? 30. And then a sub, this time I'll do n plus 1 equals a sub n. Just new term is previous term. That's all you got to know. And then what do I put to finish it off? Minus 5. Excellent. Now, for part B, I would not want to use a recursive formula for part A. For part B, write the explicit formula. Go ahead, do that now. Everybody agree? Okay. Now it wants to know the 20th term, so what do I do? Drop in a 20. Good. 19, negative 95, negative 65 is the correct answer. Okay. Hasta la vista. Vaya con Dios. Toodaloo. Ta-ta. Arrivederci. We'll do more sequences for the next 2 days. Arrivederci. Smile a lot. Ciao. Arrivederci. Adios, amigos y amigas. Very nice shirt. Smile a lot. Cutter shoes. Kebabis. Sayonara. Shalom. Ta-ta. See ya.